Now that we have examined the graph of a logarithmic function, we have a new parent function. You know what's coming, right? That means we can do transformations here in section 5.3.3. Example 4, graph the following logarithmic functions using transformations. The graph of the parent function is given. Include asymptotes on the graph and label. Also state the domain and range. Anytime we graph by transformation, we begin by identifying the parent function. In this case, the parent function is the most basic logarithmic function we can identify. That is log base 3 of x. And that's what we have graphed over here on our coordinate plane. However, I want to make sure you understand how to generate that by hand on your own. So let me give you some tips on how to get that started. I always recommend that you take your logarithmic function and convert it to exponential form. So we're going to take base 3 to the exponent y equals x. Then, to get our 3 key points, instead of choosing x values, we choose y values. So our y values will be -1, 0, and 1. When we plug those in for y into the function, we end up with these 3 key points. So those are the 3 key points that you see graphed over here on our parent function. Remember, every logarithmic function has a vertical asymptote. This one has vertical asymptote x equals 0. Once we realize that, then the transformation becomes very simple. Notice inside the argument, we are subtracting 1. That means we need to shift to the right by 1 unit. So everything from our original parent function is going to move to the right by 1 unit, including the asymptote. If the original asymptote is at x equals 0, when we move to the right by 1 unit, its new equation becomes x equals 1. Then we can take all of those 3 key points, move them each right 1 unit, and graph the new function, limiting it by that vertical asymptote. And we have our transformed function, log base 3 of x minus 1. Then the domain of this new function, the purple curve there, the leftmost x value is 1, but it's not included, so we indicate that with parentheses. The rightmost x value is infinity. And the range for this logarithmic function is the same as the range for any logarithmic function, -infinity to infinity. Looking at our next example here, we will again begin with a parent function. The parent function for this logarithmic function is y equals, and by the way, I have another typo. Please forgive me. That should be 1/3, base 1/3. Y equals log base 1/3 of x. That's the graph that's presented over here to the right. But again, I want to make sure you know how to generate that by hand on your own. So when you graph a logarithmic function, it sure is easier if you first convert it to exponential form. So we're going to write this as 1/3 to the y equals x. Then, instead of choosing x values for our t-chart, we will choose y values. So if we plug those in for y in the exponential version of our function, we end up with values 3, 1, and 1/3. And that's where these points come in the graph over here. 3, -1, 1, 0, and 1/3, 1. Also observe all logarithmic functions have a vertical asymptote. This one begins with its vertical asymptote at x equals 0. Now, once we have the parent function graphed, we can then identify transformations. Notice here in the argument, we are adding 1. If you add or subtract within the argument of a function, that represents a horizontal transformation. In this case, the graph is going to move left 1 unit. In addition, we have a -2 outside the function. If you add or subtract a number outside the function, that means it's not involved in the argument of the function. It's a vertical transformation. In this case, we have a shift down 2. So these transformations will also affect the placement of the asymptote. So let's look at the vertical asymptote, the original at x equals 0, and move it left 1 and down 2. Now, if I move it left 1, it will change its apparent position. And if I move this new location down 2, it's just going to shift right on top of itself, so no change in its apparent position. So the new vertical asymptote will be at x equals -1. Then we're going to take each of our original points, left 1 and down 2. Left 1 and down 2. Left 1, down 2. Then we can connect the dots in the same fashion that the original function was constructed. And we have our newly transformed function, log base 1/3 of x plus 1 minus 2. The domain of a logarithmic function will always be dependent on the location of that vertical asymptote. Looking just at our purple curve here, the leftmost x value is -1, the rightmost x value is infinity, and the range is lowest y value to highest y value, -infinity to infinity. So the good news is you have already learned all the transformations. We're just learning to apply it to the new parent function, which is a logarithmic function.